2018 AB free response 6. So we have a differential equation, dy dx equals 1/3 x times the quantity y minus 2 squared. First thing to note, this is a separable differential equation, so you're going to be asked to solve it. It's going to happen in part B or part C. You're going to be asked to split the x's and y's to different sides and integrate to solve. So anyway, you're given a slope field like done already for you in part A. This is a very crappy version of that because I am just not willing to put that kind of time in. So given this slope field, right, for a differential equation, they give you 2 points that they want you to plot values through. They give you the point 0, 2, and they give you one at 1, 0, right? Sketch the solution curve that passes through each one. That's all they want, right? So if you look at the real picture, please don't look at my picture, look at the real picture. If you look at the y value y equals 2, you'll see that all of these little snippets of slope are horizontal, meaning that this curve is just the horizontal line y equals 2, right? So that's the first curve, right? The first curve through 0, 2 is basically just the line y equals 2. Now, my graph wasn't terrible for that purpose. It's going to get worse, so just deal with it. Okay, so when you start at this point, if you follow the snippets of slope, what ends up happening is they kind of work their way up, and they're steep, and then they level out, and it kind of looks like this. Now, again, my graph is not doing that justice because I did not commit to drawing this slope field. And then when you follow these little snippets of slope down, they're going to start to level out again, and if you notice, all the slopes on the y-axis are horizontal. And then it's going to do exactly the same thing in the opposite direction and kind of go like this. Again, on the real slope field, it's an awful lot easier to see, right? But this is the other curve. This is the curve through 1, 0, okay? And again, it's much easier to see, but those were your 2 points, really just drawing those 2 curves. Cool. Part B, let y equals f of x be the particular solution to this differential equation with the initial condition f of 1 equals 0. Write an equation for the line tangent to the graph at x is 1, and then use your equation to approximate f of 0.7. Okay, so this is a long question, right? Like part B has several lines and several prompts, and so I think a lot of times we don't focus on the individual parts. So first part of B, we want to write the equation for a tangent line, right? So in part B, we need an equation for a line, right? No matter how hard math gets, an equation for a line means you need 2 things. You need a point, and they gave you a point. They gave you that f of 1 is 0, so 1 comma 0, and you need a slope, right? And you need a slope, and your slope is f prime of 1, right? But in this situation, that's going to be your dy dx evaluated at the point 1, 0, which you can totally do. So you're going to find your slope by taking your dy dx, right? So dy dx evaluated at 1 comma 0 is going to be a 1/3 of a 1 times a 0 minus 2 quantity squared, which would be a negative 2 squared, so that's a 4. So your slope is at 4/3. Once you have a point and a slope, you should write your equation in point-slope form. So y minus the y value equals m x minus the x value. So there's my equation. Now, if they want you to solve for y, if they want you to solve for y, you can add this number over. In this case, it really doesn't matter because that number is a 0 anyway, so it doesn't matter at all. So I'm going to use, so my f of 0.7 is going to be approximated when I use this formula. And again, if this were a number that was non-zero, you could add it over. So I'm going to approximate by adding by plugging in a 0.7. 0.7 minus 1, so that's a 4/3 times a negative 0.3, which is a negative 0.4. So that's my approximate value for f of 0.7. So again, negative 0.4, sorry, I kind of made it look like an equal, but there you go. All right, cool. Part C, very predictably, is worth all of the points in this problem. So this was a 2-point part of the problem. Part A was also 2 points. And then all the big money is in Part C, because if you are given a separable differential equation, you will be asked to separate it, you will be asked to solve it, and it will be worth 5 or 6 points on your free response. So what I need to do in part C is move my dx to this side and keep all the x stuff over here with it, and then move my y stuff over to the other side. So for part C, I will get 0 out of these 5 points if I don't correctly separate the variables. So I have a 1/3 x dx, right? So first, separate the variables, right? So separate your variables. If you don't do that, problem's over. You got all of those points wrong. now I have to integrate both sides. I have to find the antiderivative. You don't have to show a ton of work on this. You just have to be right on it. So when I go to integrate both sides, right, the antiderivative for this side, I up the power by 1, divide by the new power. So I'm going to get a 1/6 x squared plus c. I'm going to put the plus c on the x side. When I integrate this guy, it's u sub. Your u is a y minus 2, so you're actually integrating u to the negative second du, right? That's what you're integrating. If you don't need to write it as u sub, great, don't, it's fine. When you up the power by 1, you get u to the negative first, and you divide by that power. And so what's going to end up happening is you're going to get a negative 1 over u, which in this case is y minus 2. So this is the next piece I get to, right? So I have to find the antiderivatives for both sides. That's usually worth 2 points, right? So separating the variables is usually 1. Antiderivatives for both sides, usually 1 point each. Cool? Making sure you have a constant of integration. That's another point, right? Now, if the problem says solve for the particular solution y equals f of x, you have to solve for y. And unfortunately, this one said that. So when you choose to plug in and find c is entirely up to you. You could find c now if you want, using the initial condition, or you could solve for y first and then find c. It doesn't matter, but from here, those are the two things you're going to have to do. You're going to have to use the initial condition, right? So what remains, right? So right now, I probably have scored about 3-4 points on this, right? Somewhere in that neighborhood. Depends if they give me one for just c by itself. The last two things I have to do are to use the initial condition that they gave me, which is 1, 0, and solve for y. It doesn't really matter which of those you do when, but it changes the approach a little bit. So I'm going to go ahead and use the 1, 0 and find my c. You don't have to. Sometimes I solve first. It doesn't matter. So I get negative 1 over a negative 2, right, because I'm plugging in 1, 0, equals 1/6 plus c. So 1/2 minus 1/6 is my c, right? So that's a 3/6 minus 1/6. So that's 2/6 or a third. So c is 1/3, right? So now that I have c, and since I don't need all of this anymore, we'll just buy ourselves some space. Okay, so now that I have c, I know that my formula looks like negative 1 over y minus 2 equals 1/6 x squared plus 1/3. And that's not wrong, right? But it is not solved for y. So from here, I need to solve this thing for y. And there's a couple different ways to do it. You could go a really super lazy route, and there's nothing wrong with it. You could say, hey, I'm just going to multiply this guy all the way over here and make this a negative 1 equals 1/6 x squared plus 1/3 times this quantity y minus 2. And then I could divide this thing over, so you could do a negative 1 over 1/6 x squared plus 1/3 equals y minus 2. And then I could just add the 2 over. So if I want to be like the laziest human, nothing horribly wrong with it, I could make it look like this. Right? This whole thing is the denominator of my fraction, plus a 2, big 2, because it's not on the denominator of the fraction. This is one way to do this, right? Another option, if you kind of hate this fraction in a fraction look, because I'm not a huge fan of it, it's not wrong, but I'm not a huge fan of it. Another option would have been to get a common denominator here and clean this up a little bit. I'm going to argue, so you don't have to, but it's not a terrible plan. So another option, and I'm going to leave this answer here so you can still see it, but another option is before I do that, and I would do exactly the same step, but before I do that, one way to deal with this is either to get a common denominator here, or to say, man, I really hate these stupid fractions on this side. I'm just going to multiply the entire thing. My bad. I'm just going to multiply the entire thing by a 6, because that would get rid of the 6 and also the 3, right? So I'd get negative 6 over y minus 2 equals x squared, because the 6 times the 1/6, plus the 6 times the 1/3 would be a 2. Right? And if you do that, right, you can then essentially multiply this over the same way we did before and then divide this guy back, and you would get a negative 6 over x squared plus 2 equals y. I promise that this is the same answer, and you can even see it's the same answer because, y minus 2, and then you'd add the 2 over, right? So plus 2 equals my y. Sorry. So you can see they're the same answer. The other way you can see they're the same answer is if you had times this thing by 6 over 6, which you're allowed to do, you'd get a negative 6 on the top, and you'd get that x squared plus 2 on the bottom. They're the same answer. It doesn't matter. Again, there's different approaches to it. That's the idea.